CIS-332 database management system. This is day 12. This was Monday. 3/6/17. Midterm this week. We start out today. Practice number 8. Students can take a look at that. I need to post a solution for that yet. And then we start talking about talked a little bit about assignment, the individual assignment. We looked at analysis, identify the needs. So I said, what do you want? And then what do we need to get what you wanted? Design 1 for this assignment would be a diagram, something similar to or an ER diagram. Design 2, get into more specifics. We take the ER diagram and we start doing a identify your attributes, type, and so forth. We'll talk more about as we go along. So if you think about this whole process, we started out this whole idea external. People see from the top, and then we get conceptual ER diagrams, and we get the logical. We actually build the tables. Then the database management system communicates to the physical. So, we talk about data models. We've got the physical, the logical, and the conceptual. Wikipedia does a nice job with that. We talked a little bit about the example where we had the students, the devices, and the rentals. We're going to look at that a little bit more here later on. So, as we went in and started defining these attributes, then you can make a data dictionary at the same time. That can be its own separate entity. Have the word and the definition, and then you might even have a couple other areas where you define the data. Okay, a lot of pages to here. So here's an example where we talked about an entity, students, the entity were devices, and then we have a table where we're actually having the devices rented. Okay, this came from the example where at a let's say a college, students either from a kiosk or the library or whatever could rent devices, like maybe an iPad to do some special work, or a laptop to do some work, or whatever devices they had, and we could rent them out. So most of the students came up with the entities, students' devices. Now rentals, if you notice here, rentals, because of the double box, that's a weak entity. Rentals can't exist without the other entities. Without having a device and a student's entity, this entity wouldn't make any sense. It wouldn't exist. So it's a weak identity. We didn't go into all the details for this, but let's just take a look at a few of the things here. A student can rent many devices, but each device can only be rented once in the tables. If you have a rental, you must have it connected to a device, but a device doesn't have to be rented. A student doesn't have to rent a device, but if a device is being rented, there has to be a connection back to the student. Okay? So, let's look at... We talked about this in class today, so let's go through it again. First of all, let's just look at this area right up here. You'll notice this isn't complete, but let's take a look at it. Here we have an attribute. We have artists, artist name. Here's our entity. Okay. You might call it a strong entity. This is our relationship. The artist compiles an album. The album wouldn't exist if it wasn't for the artist. That makes sense? So that's a weak entity. And the relationship here, compiles, that wouldn't exist if it wasn't for the artist. So that's a weak relationship. These two lines in here are saying an album has to have an artist. Okay? But an artist doesn't have to have an album. You could have an artist that didn't create an album. The way this is set up, one artist can have many albums, but each album can only have one artist. To keep track in the album here of which artist it is, you can see here we've created, here's a primary key because it's underlined. This is a foreign key because it's dotted. Here we have the album name, and there could be many more attributes. We're going to look at some more examples. An album must contain tracks, and tracks to an album. You have many tracks to one album. One album has many tracks. And then this goes on down to some more weak entities. Was played, played. And I'm not sure, here's a foreign key, but I'm not sure where that relates back to. Okay? Now, a couple other things we need to find out here. This artist's name, that could be a composite. Right? Because it could be first name and last name. Okay. Now an artist could have an address and so forth, and a phone number. Phone number could be a composite because it could be area code, number. So we looked at some examples of that. Let's move on. Here's another example. Just take that out of there. Here we have a student. So you could ask the question, does a student have to be in a program? Yeah. If a student is in this scenario, here's a student. The two lines are saying a student must enroll in a program. They have to be in some program. But does a program have to have a student? No. There might be a program with no students in it. You know, maybe the program might be art. Maybe that's one of the programs. Okay? Now the program, a course. Does a course have to be in a program? According to this diagram, yes, a course has to be in a program. One program can have many courses. But a course, according to this, can only be in one program. How many programs can a student be in? A student can be in one program. But a program can contain many students. A student can attempt many courses. Okay. And so then we have the attributes. Like over here we have course ID. That came from another table. Okay. There's another. We're not going to go through the details of one, but here's another one where you can see mandatory, not mandatory. You see the attributes, key attribute, key attribute, key attribute, key attribute, key attribute. In this one, they're not showing any weak entities, even though there could be some here. Manager requires reports, and so forth. Here's a review. The box is an entity, diamond is a relationship, oval is an attribute, weak entity, when we have the rectangle inside the rectangle, weak relationship, diamond inside. Now if you have an attribute, that's a multi-valued attribute that can have multiple values in there. Underline, key attribute, composite attribute. This attribute has two parts. Here's another example. This is an example of orders, order author, customers, products. Those are all entities. Here we have the attributes of the entities, the attributes of the entities, attributes of the entities, and so forth. One customer can have many orders, but each order can only have one customer. One to many. An order can contain many order items. An order item contains a product. That's a one-to-one. Yeah, so one product, one order. That would make sense. Now in this one down here, they don't. Well, I take that back. They do. Here we have a mandatory requirement. An order number must be in an order. I guess that would make sense. Alright. So we talked about this whole concept then. You start out with how you want to view the data. And then we hit the conceptual view and the logical view, and then how the data is physically stored. If you remember, we have the database management system, right? And so we've learned SQL, and now we're working on learning how to design or organize a database using entity relationship diagrams. Alright, so that's it.